Hey everyone, welcome back to the range. My name is Matt, and it's 9mm ammunition testing day. I should get a different shirt for every different caliber I'm going to test, and then when I test it, I'll just wear the shirt and point at it. Anyways, I've got some more of those external hollow points to test from G9 today. Today I have their first response. I do believe this is law enforcement only. Their 77 grain, wait, that's a screwdriver bit. That's not what I'm talking about. I'm talking about this guy right here. This is their 77 grain external hollow point, all copper, loaded in these shell shock cases. Let's put him on the table and talk about what we're gonna do today. In full transparency, all this ammunition was provided to me by G9 through Botash Tactical. Someone correct me in the comments below. For all of my ammunition testing reviews, demos, whatever you wanna call them, I try to stick to the informational side of things versus pure entertainment. So I like to collect velocities from various different barrel lengths. We got a 3-inch, 4, 4.5, 7.72, and even a 16-inch barrel. After we've collected velocities, I try to do a practical accuracy test at about 25 yards for 9mm. So, you know, if we get some kind of bullet that's not appropriate for the twist rate that most 9mm is in, you should see that reflected on the target. And after that, because this particular bullet has me interested in its performance, we're going to test it in some clear gel and against some different types of barriers. Now, I've seen this testing done in the past against other external hollow points, and typically what we see are really wide wound cavities or tumbling. So I'm not entirely sure how beneficial these are in a pistol caliber versus traditional jacketed hollow points, but one thing that has my interest piqued is its performance against different types of barriers such as windshield glass, plywood, or drywall, which are usually hard barriers for traditional jacketed hollow points to make it through and actually expand and perform better than full metal jackets. I think I may have forgot to mention at the beginning of the video that this particular load from G9 is loaded in the shell shock 2-piece case. This is the second manufacturer that I've dealt with that's used this type of case. It does have the advantage of being lighter than brass. The 2-piece design allows you to reload it more times. You do have to have a special set of dies, and it also allows better handling of higher pressure versus brass or nickel or steel cases. Up first is our Springfield Hellcat. This has the 3-inch barrel. We've got the Apex trigger in here. I really like this gun for a micro compact. I especially like the factory sights on it. Not to mention the 13+1 magazines. We're only going to run 5 rounds through each barrel length, mainly because I only have a limited number of this available to me. Air, of course. A little hotter than the 80 grain off the bat, and I think they're really close to about the same grains based on the scale measurements that I took. This one may be loaded just a little bit hotter, and you can see that that bullet profile design is just a touch different. And now on to our 4-inch. This is our Glock 19 Gen 4 MLS with a Holosun 407 up top. I apologize if I move the mouse and you guys couldn't see the velocity numbers beforehand, but I always put an average at the end of each string. Ooh, almost 1,500 feet per second out of a 4-inch. Now onto our 4.5-inch barrel. This is an A-Rex Delta Gen 2 long slide. Got a Holosun 507C up top. Almost done with the review on this pistol. Really liking it, especially the 19-round factory magazines. Did I not get a velocity reading off that? Gosh darn it. There we go. Woo! Now we're getting over 1,500 feet per second. I wonder if we'll see over 2,000 with the 16-inch. And now for my favorite 9mm pistol caliber carbine. This is our CZ Scorpion Evo 3 S1 SBR. Yep, it's Form 1. That's why the vertical foregrip is up front. I've seen that asked a few times. Lots of HBI parts on this sucker. Not too bad, over 1,700 feet per second. And finally, our 16-inch. This is an AR-9 that I borrowed from a friend. Got a bunch of various cool parts on here from R.A.N.G.E. Got a Vortex spark up top. Very nice setup. Maximum velocity for 9mm. Woohoo! And that's all she wrote. Got a couple over 1,900 feet per second. That is smoking hot. Let's get set up for our accuracy test, and then we'll flip on to gel and see what kind of barriers we can put this stuff against. For our accuracy test, I place a target at about 25 yards for our 9mm. I figure that is a good compromise. We use the longest barrel length that we have available, which is the 16-inch. We have a primary arms Silverline first focal plane. 18 power scope on that bad mamma jamma. There is a little bit of wind outside right now, but it is hot today. Recorded this on the same day as the 80 grain as well as some other 9mm loads, and our results speak for themselves. Our best group was 0.542 inches. This is actually the last group. Our worst group was 1 inch right here. This was the third. Our second 0.800 inches, and our first was 0.920. Kind of getting a little bit of a flyer occasionally on these. And that last group, I took my time. I usually take a couple minutes between each group. I will fire 5 rounds, go pick up the brass, and then repeat. I'm not taking 3 minutes between each shot. I don't have that kind of patience. So this is very above average for our 9mm in terms of good accuracy. Usually when we get into the average, it's about 1 inch to 1.25 inches, and anything over that 1.5 inches is usually I don't see a whole lot of. So very good accuracy out of this all copper external hollow point. All right, time to shoot some gel blocks. We've got our 6x6x16 10% clear ballistics gel block right down there at 12 feet. Brand new block, so we're gonna be able to see those wound channels very nicely. Now, I shot the 80 grain G9 loading before we shot the 77 grain, so I kind of already know how it's gonna perform. So interesting to see what this slightly lighter bullet with a pointier tip is going to do in gel. The 3-inch will be first. Should be upper left-hand corner. Okay. Then our 4.5 inch. I'm going to try to shoot these all at once so I'm not taking up too much of your guys' time. That one I might have shot a little high. We'll go down and check that in a second. Our 7.72 inch. And now our 16 inch, this is a Palmetto State Armory ARV9. I just picked this up so I could return my friend's PCC to him. This takes CZ Scorpion Evo mags. Got a nice spot on the gel here. Good velocity, almost 2,000 feet per second. Ooh, look at those wound channels. Now with pistol calibers, you typically only see permanent wound cavities in gel. You got to get to those rifle-like velocities to see more of that stretch cavity. But those are pretty impressive for the velocity that we're getting there. Forgive me if the gimbal doesn't cooperate. But those wound channels are extending out to about the 12-inch mark. Then they settle down a little bit. Now here's where the 77 grain I think is shining a little above the 80 grain. We have penetration out to the 20-inch mark with the 7.72 inch. Then the 16 inches down there, hard to see, at 23 inches, it actually bounded off the little metal here. This guy right here, like I said, is a 7.72 inch. This guy right here at the 18 inch is the 4.5 inch. That is base forward. Down here at 19 inches is the 3 inch. That is also base forward. So interesting, slightly more penetration than the 80 grain. Give you a top-down shot of those wound tracks. These tracks may only be a representation of what you see in gel. In real tissue, they may not be the same. Our next barrier, if it will stay on our gel block, is a level 3A panel. This is the AR500 Armor hybrid panel. Our 80 grain was able to penetrate the Rime-Lig, which is all aramid fiber. And when we stepped up to the 3A hybrid, the 80 grain couldn't penetrate it even from the 16 inch because it has polyethylene in it. So we're going to start at the 4.5 inch, and if we don't get penetration, we'll skip all the way to the 16 and then see what we get from there. If it does penetrate this from even the 4.5 inch barrel, we'll go down to the 3 inch, and then I have some other level 3A with me that might pose more of a threat. That's usually not a good sign when the panel doesn't jump off the gel block. A little foreshadowing, we're going to take a shot with our 3 inch here. If I can hit the little tiny plate right where I want it. Oh, really low velocity there. I'm guessing the sun may be playing tricks on us, but let's go see what we did. All right, here was our 4.5 inch and here was our 3 inch, as you can guess. R.A.N.G.E. We have penetrations there. Our 4.5 inch made it right around 14.5 inches. And then the 3 inches right around 12 inches down there. Looks like it's somewhat sideways, but it started to dive down a little bit on me. Let's try that other 3A panel that's made out of all polyethylene and see how it handles this bullet. All right, I have our other 3A panel on our clear ballistics gel. This is from Stealth Armor Systems. This is their RZL3A. Have this for their HFRAS testing, but I figure we can take a shot off to the side and no one will know the difference. We'll take a shot with the 3 inch first and then go from there. Good velocity off that. Grab a shot from the 4.5 inch barrel. Somebody's smoking down there. Here were our two shots, the 3 inch and the 4.5 inch, those are 2 inches apart. I would consider those a fair hit, and there's plenty of real estate on this panel that shouldn't have any issues. And R.A.N.G.E, we have a penetration on the 4.5 inch there. Maybe hard to see. There is a hole there. If we come over here to our gel at the 14 inch mark right there, you can see our little copper guy there. Interesting. So there's a lot of variance when it comes to armor. There's different grades of the polyethylene or Dyneema or whatever it's called, and there's different grades of Kevlar. So it looks like this particular bullet design is like our Fort Scott munitions, and it can plow through some good armor when you give it some barrel length. Almost wonder if we need a fairly thick rigid 3A to stop that bullet. Now we're on to our windshield barrier. I have some laminated windshield glass down there that I got from a local glass place. We have it approximately at 45 degrees. 18 inches behind that is our clear ballistics gel. I have 2 blocks stacked on top of each other because in the past when I've shot some rounds at windshield glass, they deflected and went way too high or missed the blocks completely. So I want to make sure I capture the bullet in our block because I have a limited number of those panels because they're quite expensive. We'll use the 4.5 inch and then I think the 7.72 inch. Probably shouldn't have placed that dead center, but you know, it is what it is. It would appear like our 80 grain, this 77 grain has a low deflection rate. So I shot actually between both gel blocks. I'm going to take a second shot and see if I can get on the gel block. So I'll aim a little lower this time. Nice big hole there. Glass dust everywhere. Probably shouldn't be breathing that in. Hopefully with our 7.72 inch we can get a good spot on our glass and get it in the block. That better be in the block. That's a good shot right there. Aw, our poor windshield glass got a hole in that sucker. All right, here we go. Sorry this block is cloudy. All the way down to the 14 inch mark, maybe almost 15, is the 4.5 inch that we actually contained in the block. And right almost to the 16 that you see right back there is the 7.72 inch. So that's good. We are penetrating a pretty hard barrier and we're still getting adequate penetration depths. This is where JHPs can fall apart a little bit because the windshield glass destroys the bullet enough that it doesn't expand in any way, shape, or form. It usually deforms. Like with the 80 grain, we're going to use our box of truth to see if this slightly lighter bullet with the more pointy tip is going to provide us with any more penetration in our pine board. This is 3/4 inch thick. I've got, I think, 10 sheets left. I need to get some more. They're spaced about 1 inch apart. We'll do the 3 inch first. You can smell that pine board down there. About the same as the 80 grain. Our 3.5 inch made it through 6.5 boards. It almost got through to the 7th. The 4.5 was 7, 7.72 was 8, and the 16 inch was 8 boards as well. There are our bullets. The tip looks unaffected by plywood. Interesting. So these solid copper projectiles are providing us with slightly more barrier penetration, at least in wood, over a conventional jacketed hollow point. Off camera, I fired some HST and the G2 Spear Gold Dot, both 147 grains from the 16-inch and the 7.72 and the 4.5-inch. And a majority of our rounds were stopping in the 7th to 6 boards. Here's a little easy breakdown here. I couldn't recover the HST 7 boards, the 7.72-inch HST 6 boards, our G2 only 5 boards, the 7 boards there and 6 boards there. You can see how tough wood is for JHP to expand. It tries to expand, zoom in on there, but just quite can't get there. The G2 out of the 4.5-inch I think did the best in terms of expansion, probably why it penetrated the least. Off camera, I fired a Federal HST 147 grain as well as a Spear Gold Dot G2 147 grain as well out of the 4.5-inch barrel. We got to 14 inches of penetration with the HST, but only 11 inches with the G2. You can tell how hard windshield glass is on our bullet. Beats that guy up pretty well. It did expand a little bit, and it is larger than its original diameter, but we don't have uniform expansion. Figured I'd wait until we were finished with all of our bears and we just lay these out in a column and row format so you can get a look at them. I'm not going to take any macros of this particular bullet design because for the most part the bullet shape and everything remained the same throughout all of our testing. You know, here's our bear gel up here all the way through 16. Here was our 3A. We started to deform that tip a little bit. And then when we get into our windshield glass, you can see we've got more deformation going on there. The 4.5-inch actually brought some of the laminate with it, it looks like. Very interesting. But otherwise, not much, you know, over the actual diameter of the bullet from that deformation. And then we get into our wood, those things look just like the bear, unobstructed, undeformed, like brand new. Probably could reload those in a gun if you wanted to. Well, I hope I didn't bore you all to death with all these rudimentary barrier and gel tests. When we get outside of our conventional jacket hollow points in our pistol calibers such as 9, 40, and 45, I try to run some tests on these bullets to see how they stack up against those tried and true designs. After all, there is a good chance that occasionally you get a bullet that is a 100% marketing bullet and 0% performance. I don't think that was the case here today with our G9 Defense in 77 grain. We had more than adequate penetration depths to the FBI standards, you know, over 18 inches in all of our barrel lengths. We even had good performance against all of our bears, especially the 3A compared to the 80 grain loading. I don't remember if I mentioned in the beginning of the video, but the 77 grain is limited to law enforcement only. Not sure why. I should be able to buy it because there's nothing restricted about it. It's just a solid copper. But that's an entire different discussion altogether. We had good velocity and our accuracy was exceptional as well. As I close out all these videos, I take a moment to thank all those who helped make these possible. Number 1 is my Patreon supporters. Number 2 is Botac Tactical, who got me in contact with G9. 3 is G9 for sending this ammunition over for me to test with no strings attached. And then today, number 4, you all for watching. Until next time, I'll catch you at the range.